Alright class, we're going to do more graphing rational functions on day 2. Again, all of the steps are the same as yesterday. They are listed there for you, so let's begin again. So number 1, I already have the top factored for you, so we just need to factor the bottom, and hopefully you guys realize that 3 times 1 is 3 and 3 plus 1 is 4. So we can do this. Now today you're going to notice a few new things that we didn't get to yesterday. For example, we have to reduce this, and this does reduce into x plus 2 quantity squared over x plus 3. Okay, which means there's a hole at x equals -1. It's whatever makes the thing that cancels 0. So now you have to plug in -1 into the remaining. So we get -1 plus 2 is 1 squared is 1. 3 minus 1 is 2. So 1/2. So there's a hole at -1, 1/2. Okay. Next, we are going to do the x-intercept. Just like yesterday, that is when the numerator is equal to 0 in this case, when y equals 0. So the numerator. So when we set the numerator equals 0, all we have left is the x plus 2, and we get x equals -2. However, so we get the point -2, 0. However, this is even, which means it's going to bounce off the axis. So remember that. Now, y-intercept is when we stick in a 0 for x. So I'm going to say f of 0 equals, and then we get 0 plus 2 squared over 0 plus 3. So we get 4/3. So the y-intercept is 0 4/3. And again, there's no multiplicity for that. The vertical asymptote is whatever's left on the bottom equal to 0, so the denominator equal to 0. So I say x plus 3 equals 0. X equals -3 is my vertical asymptote, and it is odd. So it will switch from positive to negative over that vertical asymptote. And then for oblique and so if you notice, this, either one you can look at, the top is x squared, the bottom is an x. So what you can say is our highest degree on top is x squared, our highest degree on the bottom is x. For graphing purposes, you don't have to do synthetic division or anything, just simplify those terms, and you get y equals x is our oblique asymptote that we're going to use to graph. Alright, so now let's try to graph this and see what happens. So I have an oblique asymptote kind of going y equals x, which means it's cutting right through the graph here. Okay, there's my oblique asymptote. My vertical asymptote is at -3, so that's right here, 1, 2, 3. And it is odd, which means that it will switch sides. I have some points. I'll put those in red. The hole is at -1, 1/2. So I have a hole here. I have a y-intercept at 0 4/3, which is right here. And I have a 0, an x-intercept at -2, 0, and it bounces. Okay, and I think that's all. So basically what you should see here with these 3 points in a row is that this is going to kind of go off and follow this asymptote line. It's going to come down here. Now when we hit this -2, the -2 was even, so it's going to bounce up. And because this asymptote is odd, that means on the other side we're going to start down here. But then remember, with these asymptotes you kind of follow it back to the side. So it kind of looks like a weird X shape. Okay? And that's it for that one. We have one more. Again, first thing you should do is start by factoring. Since it's already factored, you don't have to worry about that anymore. Next thing we got to do is reduce. So this ends up being 3 over x minus 2 quantity squared. Because the x minus 4 factor is reduced, you know you have a hole at x equals 4. So now you just plug that in. So when you stick the 4 in, you get 3 over 4 minus 2 quantity squared, which is 3 over 2 squared, which is 3/4. So you get the point 4 comma 3 over 4 for your hole. Again, for these, the x-intercept we set, it's when y is equal to 0, and when it's a fraction, that means the numerator is equal to 0. Since there's nothing to make the numerator 0 for this, though, there are no x-intercepts for this one, because you can't make the top 0. Unless you could somehow magically turn a 3 into a 0, which you should not do. Alright, y-intercept was when we make x equal to 0. So when you solve for f of 0, you get 3 over negative 2 squared. This is actually very similar to the whole. You get 3/4. So our y-intercept is 0 3/4. The vertical asymptote is when you set the bottom equal to 0. So that's the denominator. When you set the denominator equal to 0, you get x, what was that, 2, minus 2 down there? Yeah. X minus 2 equal to 0, so x equals 2 is your vertical asymptote. However, since it's squared, it's an even asymptote, so we'll have to remember that while we're graphing. And the last step is to look at the powers on top and bottom. Since you have just a number on top and x squared on bottom, it's bottom heavy, which means it automatically is y is equal to 0 for the horizontal asymptote. So, now we're going to put all this stuff on our graph again and figure out what it looks like. Remember the x, the vertical asymptote at 2 is even, so let's mark that down. And what else do I have? I have no x-intercepts, which kind of makes sense because our end behavior is at 0, which doesn't always mean that it won't cross, but in this case it does. Our y-intercept is at 3/4, which is right here, so that kind of gives us an idea of where the line's going to be. And we also have a hole at 4 3/4. 4 3/4. So there's a hole there. So because the y-intercept is up here, we know the line has to approach this vertical asymptote and go through it, so it's going to look something like this and then go off forever. And since this vertical asymptote is even, we start on the same end that we did for the other side. So we're going to come back from this top here and go through the hole and then go off to the horizontal asymptote. And so this makes sense because we do not have any x-intercepts and we do have an even asymptote. Alright, as always, remember you do not get your calculator for this. However, if you want to quickly check just to make sure you're doing it right, always feel free to do that. I will talk to you guys later.